Today we're going to look at an example of how we solve simultaneous equations by elimination, and our two equations are 6x minus y equals 10, which we're going to call equation 1, and that's really blurry and we can't use that. This example of solving simultaneous equations uses the elimination method. So what we're aiming to do here is to eliminate or get rid of one variable altogether. So we're left with one equation and one unknown. So we're going to begin with two equations. We've got 6x minus 2y equals 10. So we're going to call that equation 1. And 2x plus 5y equals negative 8, which is equation 2. Now when we're solving by elimination, the best thing to do is to set these up one under the other. So we've got equation 1, which is 6x minus 2y equals 10, and equation 2 is 2x plus 5y equals negative 8. Now the reason that we set these up one underneath the other is we can easily see if there are any relationships here between the coefficients of our x variable or the coefficients of the y variable that will allow us to easily eliminate one of them. So what we can do here is we can say, well, if I multiplied equation 2 by 3, so we multiply everything by 3, we get 6x plus 15y equals negative 24. So that's 3 times 2 gives me 6, 3 times 5 gives me 15, and 3 times negative 8 gives me negative 24. And I'm going to call that equation 3. So what I've done is I've created an equivalent equation to our first one. So now what we're going to do is we're going to use equation 1 and equation 3 to solve our problem. So equation 1 is 6x minus 2y is equal to 10, and equation 3 is 6x plus 15y is equal to negative 24. So we've got 6x here and 6x here. So to get rid of the term 6x altogether, what we need to do is we need to take equation 3 away from equation 1. So you can see that down the side here, I'm writing each of the steps that I'm doing so that it's quite clear with my communication what I'm doing. So now, if I take everything away, that means I need to change all the signs, because if I put a minus in front of this in brackets, the minus 1 will change everything through. So this one will become minus 6, we'll have minus plus 15, and we'll have minus 24. So of course two negatives add together or become a positive, so they combine to create a positive. My positive and negative combine to create a negative. So I have 6x minus 6x, so that becomes 0. I have negative 2y minus 15y, so overall that's going to give me minus 17y. And I have 10 plus 24 is 34, so therefore I have y is equal to 34 divided by negative 17, because I'm dividing both sides by negative 17, which is equal to negative 2. So we'll call that 4. I now have half of my answer. Now I need to substitute that back into equation 1. So I'm going to substitute 4 into 1. And that will give me my value for y. So I have 6x, because x is the one that we got rid of, minus 2 times negative 2 is equal to 10. So all I'm doing is I'm putting this value up here into y. So 6x minus 2 times minus 2. So minus 2 times minus 2 is plus 4, which is equal to 10. So 6x is equal to, if I take 4 from both sides, I'll get 6, and x is equal to 1. So now I have my answer, or what I think is my answer, and that is therefore x equals 1 and y is equal to -2. Now, just to be sure, I'm going to do a checksum, and I'm going to check using equation 2. All right, so our original for equation 2, our left-hand side was 2x plus 5y. So I can say 2 times, and I've got 1, plus 5 times -2, because my -2 here. So that becomes 2 plus -10. So my two signs combine to give me a negative, which is -8. 2 minus 10 is -8. And we can see that that equals our right-hand side. Therefore, my check works, and this must indeed be my solution to this problem.